right, hi folks. I'm making this video here to get us rolling on section 1.6. So before we actually start looking at some of these problems, right, let me point a few things out. So imagine we were looking at like, an equation that said something like, all right, come on. There we go. Square root x equals 16. Whoops, no, not 16. 4. Now, the solution to that would be x equals 16. And you get that by squaring both sides. But one thing I would like to point out, right, is that if we write this in like power format, square root of x is x to the 1/2. And when you're looking at powers, what we're doing, when we're squaring both sides, this is what we're doing. We're taking x to the 1/2 and we're raising it to the second power. Right? And from a power standpoint, right, this is now x to the first equals 16. So, looking at a little more complicated example, if we had, say, x to the 3/4 equals 2, I'm just making up a number here. Again, this means the 4th root of x cubed. And, we could solve that by taking the, let me back up. The way we solve this is by raising this to the 4/3 power. And again, we do both sides. Because now x to the 3/4 and then applied to the 4/3. Remember, you multiply your exponents. This is now x to the first equals 2 to the 4/3, which is some numerical value. So that's kind of the process we're going to use when we solve these things. But there's a couple little details here that are going to be important that I'll point out as we move along. So we're going to take a look at this one first, right? And this reads x to the 6/7 equals 5. So this is solved by raising this to the 7/6 power. Now, 5 to the 7/6 power, right, is just some number. And you'll notice that in our solution set, here it is basically. But you'll notice there's two of them. You might wonder, well, why is there a plus and a minus? All right, because when you look at this, x to the 6th power, if I write it in radical form, this means the 7th root of x to the 6th power. Now, one thing to notice is when you take x and raise it to the 6th power, you're going to get a positive value. So there's actually two different numbers, one plus and one minus, that yield the same exact number under this radical. And that's why there's two solutions here. So that's something to just be mindful of as we solve these. Right? So let's go through and look at a couple more. All right, so this one right here. This one is going to be solved by taking x to the 2/9. Let me recopy this. And we're going to raise it to the 9/2 power. Now, 7 to the 9/2 is just some number. What that number is right now, not important. We're just going to leave it like this. But again, this is the 9th root of x squared. So x squared is positive regardless if x is a plus or a minus. So this actually, again, has two solutions to it. And there's our solution set written out. Okay, so this one, all right, this one's a tricky looking thing here. This one, what we're going to do is we're going to apply kind of an algebraic substitution to. You'll notice that, all right, x to the 2/3 right here is equal to x to the 1/3 squared. So what we're going to do before we solve this is we're going to make a little algebra substitution. We're going to say I'm going to call it u equal x to the 1/3. Now, why u? It's just a name. Call it anything you want. You could call Bob if you wanted to, but it'd be a lot to write, Bob in the equation. But you can call that anything. I'm just picking a letter and assigning it to that. So the reason for doing that is because this term right here is now u. And this is now u squared. And now what we have is just a standard quadratic, just like we're used to seeing. This one kind of looks like maybe it factors. Kind of think about this here. Factors in 9 are 3 and 3. Nah, I kind of doubt it's going to factor. I don't see any way we're going to get a 7 out of it, so I'm not even going to bother. I usually just recommend, give something about 30 seconds. If you can't factor it in 30 seconds, just go to the quadratic formula. All right, so u is going to be the opposite of b, is -7, plus or minus the square root of b squared. Now, b is 7, so b squared is 49, minus 4ac. And again, the a is 1 because, basically you can think of this as 1 times u squared. Make sure you get this, that the c is -9. That's important. And then all over twice a. Well, 2 times a is just going to be 2. Now we're going to clean it up a little bit. -7 plus or minus square root of. All right, so now this is positive now. So that's 49 plus 36. And let's see, what is that? 15, 85, I think that is. Yep, 85. Root 85 over 2. Now, this doesn't look like it's got a nice even square root to it. That's okay. Okay, so now what we're going to have is u is equal to -7 plus root 85 over 2. Now that's some positive number, and I don't have it. Okay, give me a moment here. I guess I do have a calculator. Maybe I should have just lied and kept going, but okay. So what I get out of that is about 9.22. So we get -7 plus 9.2 over 2. I get 1.1 for this solution. And then the other one is -7 minus 9.2 over 2. Let's see, that's minus 16.2 over 2. That's minus 8.1. Now, this thing is not done quite yet because u isn't what we were looking for. We were looking for x. So remember, this u is x to the 1/3. So we have x to the 1/3 is equal to 1.1, and the 1.1. And this is solved by cubing both sides. I get 1.33, give or take. Other solution is x to the 1/3 equals -8.1. Now you might wonder, does this have a solution? And the answer is yes, because this is raised to the 3rd power. We're going to get a negative number out of this. And 8.1 to the 3rd power, 531.4, and it's negative because you take a negative to the 3rd power, you get a negative number. So that's what I got out of this. My spidey sense is kind of going off here, telling me that, maybe I potentially have an error here somewhere, but if you give me a moment, I'm just going to kind of glance this over. Going to the beginning, u squared plus 7 minus 9 equals 0. I'm just going to check my quadratic again. Opposite of 7 plus or minus b squared minus 4 ac over 2. 49 plus 36. 1585. Okay, it looks good, so I'm going to go ahead and move on. So there's our 2 solutions. Let you folks check it and come to class and yell at me if there's a mistake. All right, now we're going to talk about some of these absolute value ones. Absolute value equations are very kind of nice to solve. Let me start with this. Right? If you had the absolute value of x equals 4, there's 2 solutions to that, because the absolute value of 4 is 4, but the absolute value of -4 is also 4. Right? Absolute value means distance to 0. So this has 2 solutions. X could be 4 or x could be -4. So anytime you're undoing an absolute value, you will typically have 2 potential solutions to think about. So when we take a look at this one right here, absolute value of this, the 4x minus 1 equals 8, has the following possibilities. 4x minus 1 might equal 8, or 4x minus 1 could equal -8. Either of those yields a true statement here. And now we'll just solve for x. So this one is going to be 4x equals 9. X equals 9 over 4. Second one, 4x is equal to negative 7, right? If we take negative 8 and we add 1, and therefore x could be negative 7 over 4. And this is done. And then in set notation, like your homework likes, it's the set containing negative 7 fourths and 9 fourths, and order doesn't matter in set notation. All right, here's another one of these kinds of problems that you're going to see in your homework, right? Things like this. Now, general rule here, third power things as a rule of thumb can be very, very difficult to factor. So, or can be a mess. Some of them are reasonably doable, some of them not, but the ones you're going to get probably will be easily factored. A lot of these will factor by grouping probably. So let's try this. Right? And again, when you're solving by factoring, you want a 0 on one side because we're using that cool property. Remember the a times b equals 0. I think on the board I put a times b times c. It doesn't matter how many of those you put, but we need this, a 0, to take advantage of this property. Now what we'll do is just kind of start monkeying around with it. Like here, x squared is common to both terms. And we get this. And here, negative 9 is common to both terms. And we get this. So again, you know, this takes a little bit of experience here when you're factoring, but always when you factor, make sure that, say, like this times this and this times this is equal to the line we got before, and it is. We're looking good. And now notice that x plus 1 is common to both terms. So now that can be factored out. And you got to learn to just kind of see x plus 1 as some item, something. And then here, when we factor the x plus 1 out, we're left with the x squared. And here, we're left with the minus 9. Let's do that, equals 0. And now we have the product of two things. 1, 2, sorry about my crummy writing there, equals 0. So possibility number 1, perhaps x plus 1 equals 0, in which case x would be minus 1. Or perhaps x squared minus 9 equals 0, in which case x squared is equal to 9, and that has solutions of x equals plus or minus 3. And I'm looking up at our solution set here, and we're going, yay, and we'll move on. Here's one for you folks to do. So please try to have this done before class time. Again, get it equals 0. That's step 1. And then try to factor out like terms. And you'll notice here too, by the way, if you take 81 times 2, you get 162. So 81 is common to both of these terms here. So, and it's going to work out very similar to the previous problem. I'm going to let you folks do that. So similar kind of thing here. You know, this thing looks a little bit ugly here, but again, we want a 0 on one side. 49y cubed minus 3 minus y minus 147y squared equals 0. You can kind of look at that and kind of think about it. One thing I notice is I just took 147 and divided it by 3 and got 49. So these two things have quite a bit in common, this and this. So I would recommend, or what we're going to do here is regroup this. Okay, 49y cubed minus 147y squared minus 3 minus y equals 0. And now we can factor 49y squared out of these two terms. And here we'd be left with a y. And here we're left with a 3. All right. Here now, ooh, that looks a little bit not what I was expecting. I got to go back here because this doesn't look quite like I'm expecting. Ooh, whoops, I made a little bit of a glitch here. Sorry, folks. In this step, when I went from here to here, I do not feel like redoing this video. So what I'm going to do is just talk about where I screwed up a little bit. When you move this term right here to the left, you need to add it to both sides. That means this was supposed to be plus right here. And that makes it following through a plus right here. It makes that a plus. Okay, now this looks more like I was expecting. Sorry about that. Make those changes in your notes. Okay, here now, if we factor out -1, right, we'd be left with a 3 plus y. See again how this is -3 and -y. Okay, now you'll notice that y plus 3 is common to both terms. So y plus 3, and now we're left with 49y squared minus 1 equals 0. And we'll use, and I'm going to bring this over here to start working. Now I'm going to use that beautiful property, the product of two things equals 0. So one possibility is y plus 3 equals 0, in which case y equals -3. Other possibility, 49y squared minus 1 equals 0. So y squared is going to equal 1 over 49. Sorry, I skipped a little bit of algebra there. Which has solutions y equals plus or minus 1/7. And we take a look at our solution set and we are happy. Okay. Now, I'm going to let you folks work on a couple of these here. So I'll let you folks, right, students, you folks do this one. I would move the 1512 to the right. I suspect 1512 is divisible by 7. Factor out a common denominator. You're going to end up with a quadratic term. Then use the quadratic formula, and that's where these are going to come from, no doubt. That's what's going to happen there. Just kind of thinking this through. Oh, whoops, I got to back up a tad. I'm sorry. Let me get the first step here for you. 7x to the 4th minus, let's see, 1512x equals 0. If you factor in 7x out, start with that. Pretty sure this will be divisible by 7. Here you're going to have an x to the 3rd minus, and here you're going to have a number, right? This is now going to be the difference of two cubes. So you're going to do another factor, and you'll end up with a quadratic. And then the quadratic is going to yield these two terms. So please give that a whirl. Try to have that done by time class comes, and if you're having trouble with it, we can take a look again during class time. This one's very, very similar. Write it 2x to the 4th minus 2000x equals 0. Factor a 2x out. That's going to be your next step. This is going to be the difference between two cubes. Factor it a little further. And then apply the rules that we've been using. Okay, so equations that look like this. Oh, these are fun. So to get rid of this radical, what we can do is square both sides. And if we do, we're going to get 3 minus 2x equals x squared. Now, there's a little thing that you have to be very cautious about. Let me kind of write a little example over here. Let's say that we had x equals 4, right? That's a kind of simple equation there, okay? And, you know, it's an equation. You know, we can think of it as such. If I squared both sides, now I'd have x squared equals 16. Now, -4 solves this, but doesn't solve the original. So you got to be very careful. When you square both sides, it's quite common that you will now have a number that does solve the equation that does not solve the original. Please keep that in mind when you're working any of these, anytime you square both sides. So I just squared both sides, and right there I always like put a, you know, like a bing, 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 like one of these. Be cautious here because I probably will have introduced something that won't work. Okay, now I would say we probably want to write it like so. And all I did is added the 2x, subtracted the 3, and kind of rearranged the equation. This thing factors, no doubt, pretty sure. Let's see, factors of 3, 3 and a 1, and I think we want plus and minus to give us this. Hopefully we've been working on our factoring skills. So this has two solutions. X could be -3 or X could be 1. Now, one thing you always want to do is check your solutions against the original. If we try the 1, happy days. The 1 works. I can already see it. I'll leave that for an exercise to the learner here. If we try the -3, right, kind of by definition here, when you take the square root of something, that's called the principal square root, and that's a positive number. And if we put the -3 here, we got a positive number on the left and a negative number on the right. And these are not equal. So this one right here, we're going to toss out because it does not work with that one. That's why the solution set here has only one value. So I'm going to let you folks do this one and this one, please, for class time. Try to have those things done. And I think what we'll do is I'm going to stop this video right here because I see it's getting a little long. It's 21 minutes here. I like to keep my videos shorter than 20 minutes on the absolute outside. If you could have this done to this point right here, that would be wonderful. I'm going to plan on picking up right here when we come to class on Wednesday. I'm going to assume you have done everything previously that I have asked. However, if you can't get one of these done, we'll take the time and go over them, right? So that'll be a big help. Keep us on track so that we can spend more time practicing for your test and reviewing and things like that. So everybody have a great day. See you Wednesday.